Welcome back to Inside Builder channel, my dear friends, Python automators and artificial intelligence enthusiasts. Mastering Towhee pipelines with open source models. Supercharge your embedding pipeline. The challenges solved by Towhee pipelines. Towhee's hub holds a lot of open source models and also functions related to various modalities that we want to work with. It has an easy download and a very intuitive interface, and it can work with tabular data frames like very easily. These are the major challenges it solves, and also it provides multiple ways to work with the tabular data as well as the data that is available with us in unstructured format, that is available in your folder, available in the internet as links. All these things you can work with various modules that is inside Towhee. I'll be providing some of the introduction of that particular modules in this video. If you are new to this Towhee as well as artificial intelligence or large language models, I would suggest that take a look at the playlist that I've already created for both working with mastering NLP with Hugging Face and related models, and also working on LangChain and large language models like OpenAI, etc. in this particular playlist. So you can take a look at this. You will have some you will get some good idea about it. When it comes to Towhee, their documentation is extremely good. So you guys can take a look at that. And also this is the website where you can, it's an open source project where you can learn about this project in detail. The point I wanted to make here is that about their operators. So if you click on their document, if you click on this operator link, you will get to the operators page where you can understand what are the various models that they host for various modalities. When I say modalities, the idea here is that image is a kind of a modality. Audio is also a modality. And there are image and text modalities like you see here, and also video and text. We have natural language modality, that is text embedding. The idea here is that we as a ecosystem that we are right now working on, we have to convert all the unstructured data that is available in the real world to structured data and also vectorized data. That is more important. You have to convert the image or audio or whatever the data that is available with you into proper numbers, that is vectors, which can be fed into models and then get the prediction. This is the process you need to follow. Towhee, what it does is it creates a pipeline around this process. So getting back to the presentation, that's what I was telling. Mastering Towhee pipelines with open source models. The pipeline here refers to the machine learning pipelines, not the ETL pipelines that you're looking for. Yes, ETL pipelines are there for the regular data, which is already structured. Like when you are working with Pandas Dataframe or a PySpark data frame, the data is already structured and it is given to you as a text, or it is put inside the tabular column and given to you for a certain level of processing. But here, when you are going to work with, for an example, a picture. So let me show you the picture that we will be working with. Let us go to the actual example that I'll be sharing. So there will be lots of pictures that I'll be sharing with you guys. This picture is already available inside the GitHub repo. This particular code or this Jupyter notebook will be available in this repo. The link will be shared to you in the description of the video below. You can take a look at that and you'll get the entire detail. This particular link, images were taken from Pixabay. Thanks to Hong-san, Bibeti and Storm22k for sharing this image in the Pixabay. And I'll be using those images. I've already downloaded those images and placed it inside unstructured exploration folder. So you can get those images from here. Okay. And also the test.csv, the file that we are working on, that is also, it's a very small file that we're working with, because I am actually showing you how to work with data frames in Towhee. That is the thing. And also I suppose that we can take a look at the pictures here also. I suppose we can open it. If not, then we can see that. So we see the entire picture here. So this is the picture that we'll be working with inside this area. Now going back to the presentation, the point I was trying to make is that the Towhee pipeline goes beyond the regular ETL pipelines in a couple of ways. First is it actually provides an exception safe handling. When I say exception, when your exception is regular errors that you get in any of the pipeline. In the pipelines, whenever you get an error, what will happen? The pipeline will break. The process will not continue, right? So if there is something wrong with the data, it will not continue, right? But in case of Towhee, there is a way to make it exception safe. So that also you can code, and it also provides lazy evaluation, like how it is provided in the Spark environment, or Spark environment in big data. If you guys are not aware of big data, if you guys are not aware of lazy evaluation, don't worry about that. I'll be explaining to you how it works in a couple of minutes. And even when it comes to evaluation of the stages or steps, there are multiple ways to work. So this video will provide you how to do that in Towhee. If you have not heard of Towhee till now, and if you want an introduction, I would suggest that go to this particular playlist. So you can take the view of this playlist, Mastering NLP Hugging Face, and in that I not only introduce the various open source models available, but also I introduce Towhee, and also I introduce various other methods of working with open source, the way of deploying the open source models in SageMaker and various other areas. So this particular playlist will be something that you guys can follow. Getting back to the presentation right now, what I want to do right now is that I want you guys to take a look at this particular repo called as Towhee IO examples. This has a lot of very good examples. First of all, start this repo, and you can fork it out. I wouldn't suggest you guys to fork it out. All you need to do is take a look at their repo, take a look at their Jupyter notebooks, and practice it. Okay, that is the primary point that I want to make. And also you can take a look at this particular Jupyter notebook that I host in my repo that introduces the concept that I'm going to discuss in this presentation. So with this, guys, I would like you guys to share this particular video and subscribe to my channel. So further updates on not just open source models, but also on artificial intelligence related topics, big data related topics, and Python libraries, I'll be sharing it in my YouTube channel. If you subscribe, it will directly hit your YouTube dashboard whenever I upload the videos. With that said, let us go to the browser and start working on the pipelines. So all my Jupyter notebooks will have the various libraries that needs to get installed. So here I not only install Towhee, I install various data science related libraries here. I also install OpenCV, that is image related libraries also. So just go ahead and install these things. And most important point is I am showing it to you in Collab Notebook because you guys can practice it in Collab Notebook, but then move this notebook to your local environment and try to execute it. That is very, very important. Only in your local environment you will start facing challenges in terms of pip installation, in terms of Python versions, in terms of various other dependencies that might be missing in your local environment. So try to find that out and discuss those things in the YouTube comment section so that others can also learn. Now moving forward, first I am trying to work with the 3 images. So 3 images are already there in this place. So you can upload the 3 images by using this upload option. I am using it as an array. So this is the point. So I have collected the images path as array, and what I'm going to do is first method. So I told you, let us go back to the presentation. I had informed you that we can do the ops in multiple ways. So you may not be knowing what is ops, and you may not be knowing what I'm talking about. So ops are basically operators. The short form for op, the actual meaning of ops is operators. And what we are going to do is the ops can be used in multiple methods. So you can use method chaining on data collection. Okay, let us go one step back. I'm sorry that this is becoming a recursive process. What happens in case of any of the Python library is that, let me lay a ground level understanding for you guys. In any of the Python libraries, there are the library specific objects, data structures. And these data structures and objects have their own set of modules and also their own set of methods on which it can work. Okay, in that way, we have Towhee. Towhee has a module called as ops, under which there are lots of methods that can actually work with multiple different models. And another object that Towhee model has is called as data collection. Data collection is again a data structure inside Towhee, I will refer to this particular data structure as DC from now on. Okay. This DC has various methods which can work with this ops module, and it can change the contents inside the DC data structure in the ways that you want and get the embeddings out of it. Final goal, keep this in mind, the final goal is to get the embeddings. Okay. The challenge that we will be facing in the near future will be embedding everything that we get our hands on, whether it is audio, video, picture, text, whatever it is, we would want to embed it. And once you embed it, then only the models can see the data. The models cannot read your picture, it cannot read your text, it can only read numbers. Keep this in mind again, it can only read numbers in form of vectors. A number, for an example, 1 or 2 or 3 is just a scalar, meaning it does not have any kind of direction. But when you are going to give a series of number in form of a kind of an array, you can actually work with that series of numbers as a vector. So easiest example that we can provide is, so let us take this point. Okay, if this is the graph, if this is a graph, assume that this is a graph page and this is a point, the 0.0 origin is here. And how will you refer to this particular point? So you'll refer to it as, for an example, 1, 2. So 1 in X and 2 in Y, right? So this has it is not only providing you how far away the point is, it is also providing in which direction how far away it is. Like in X direction it is 1 unit and in Y direction it is 2 units. So this particular point is a vector. This is a very simple explanation, guys, and you might actually think, Kamal, how is this going to help me in working with unstructured data? I am really not going to enter into any of those theories in this particular video, because the theory part is what done by the data scientists, machine learning experts, and various other scientists who are working on this and researchers who are working on this. What we are trying to do is that we are going to take the research, we are going to understand it, okay, and we are going to implement it in Python. So the process that we are going to follow is a little bit different. So without further ado, let us go into the browser and start working on the actual examples. So I had already shown you how to work with this data collection, right? So we have the list of pictures here. I shown you how the pictures are, and this path is as a list of the list of paths that you have got. And I am using the ops, as I introduced already. I am using the ops module, and I am pulling the image decode function, and I am using the image embedding function and TIM. TIM is the PyTorch for image modeling. So this is the module that can work with various models inside Hugging Face, and it can pull the model to your local environment. So you see this, you can get the details regarding that, and you can also read about this here. So if you go to TIM, so it is inside the image embeddings. So all these image embeddings work with PyTorch. It can work with various other modules like TensorFlow and also Flax. So you can read about that here, and you see that most of the models will have TIM backbone, because the starting point is all with PyTorch and related libraries. Whenever you are going to pull, for an example, if you say image embedding.data to vec and you give the model name, so this particular model name will get pulled into the environment where you are working. So here, instead of using ops.image embedding and TIM, if I say come here, if I say image embedding.data to vec, it will automatically pull the necessary module. So go through this, and the practice that you need to do here is that come here and instead of using image embedding.tim, try to use other models. And tensor normalization is a process of making the vectors normalized. The purpose of making it normalized is that if there is any outliers, it can be easily managed when you are going to take it for the next step. So once you have initiated all these three, once you initiate the image decode, image embedding, and image normalize, it will not immediately pull them. When it will pull is when you're going to use it on the image. So I have the path. The path is the variable that I am initiating using the 3 images. 3 images this particular list, and I am going to send the path. So I take this path and send it through the decoding process. So it does the decode. Then I send it through image embedding. I am sending the image into image embedding, and then I am sending the embedding and making it as a normalized vector, and then I am appending the vector into the result. You see the pipeline, how elegantly it goes through the process. And if you think this is elegant, now just look at the next one. You can just use map. So I can use this as a data collection data structure. So 3 images is the list of the path. I don't need to give even any of those vex images and embedding. All I need to do is map. So what will happen is it will take the image from the path, it will decode it, embed it, and then normalize it, do it all in single stage by stage. Okay, this is the second way. I told you multiple ways, right? And the third way is using it as a simple function. So you are just chaining it. Here, even you are not using map, you are using a simple chain of activities that we are doing on the data collection data structure. So DC data structure, I was telling you, right? So all this here you see TW is imported as Towhee. So sorry, Towhee is imported as TW. Sorry for that. And we are using that. So going back to the presentation for a moment, I was telling that we can use ops in multiple ways, correct? So this is what I was talking about. So you can use it as a dispatcher, you can use it as a function that can be mapped, and you can use it as a regular function that you can run through the for loop. All these 3 are options are available for you. That is very important because, okay, let me go to the presentation. Why all these 3 options? These options are required when you are going to work with different kinds of environment. So there are some data sets which will have lots of information. So there might be some information which might actually create errors. So at that time, using this method, method of dispatching will be very useful, because let me go to the end of this notebook. I will show you something. So there is something called as exception safe, and using this particular function, and if you use fill empty or drop empty, so take this particular functions, and if you place it inside here, I'm not going to give that example. So you place it here before you start the entire pipeline. It will check the images if there is any empty image, and it will immediately discard the empty image and start working on those image only which has data. So like this, there are lots of additional benefits when you're using such kind of chaining, right? This is what I want to introduce in this video as a first step. And second thing that I wanted to introduce is tabular data. I already showed you how the test.csv is looking. It's a simple file, and I am creating. So first of all, I am creating 2 things here. The ID, I am taking the ID, this is already available inside the CSV, and I am creating a new ID. And this new ID, how I am creating using the function called as lambda. So the lambda function I am using, and I am appending this. This is a very simple activity that I'm doing by using this function called as run as operator. So run as op, and this is one of the steps that you can do with the tabular data. And when you are doing run as op like this particular function can be any function that you're going to push into it. So what this means is that if you come down here and you take the image decode function and place it here, it is going to do the same activity, and instead of placing the new ID, you will be getting the decoded data here. So think about it. What will happen is you can start working on your data frames. So I will be showing how to work with data frames also. So next is you create a data frame, the TSV file, and you can convert the data frame into Towhee object. And that will, again, after you convert it to Towhee object, then you can work the same way how you did this run as op. So you can do that also. So it actually opens up a huge amount of benefits when you are working with Towhee pipeline. This is one of the libraries that has blown my mind away. From yesterday morning I have been working on this, and there are lots of things this library can do. I'm just scratching the surface of this. I'm just showing you what is possible with the data frames, but believe me, this when you actually pull in the huge amount of data that you have in your, for an example, in your work or in your various tasks that you are doing in your data science, this library can make your life very, very easy. And you can also create the data frame and convert it into entities. You remember the entities that I shared it to you in the earlier video? Take a look at that, you will understand what I'm talking about. And also you can use the functions that you create. So this also I explained earlier. So you can use the functions that as an ops, and you can send it through the entity, and you can create the data here. And again, as I was telling you, you can use the run as op and use the function and also create the tabular data. So all these methods are available in Towhee. So Towhee is not just a library that, let me go back to the presentation. It's not just a library that interfaces with the open source models. It can actually supercharge your embedding pipeline because it can work with tabular data. So you take the embedding, you put it inside the tabular data, you convert the tabular data into CSV. You can do whatever you want, right? So if you have the vector stores inside your Pandas data frame, then think about the power you have. So you can do a lot of activity in Pandas data frame, right? And I know a lot of you guys, including me, are struggling with vector stores. So we are trying to work with various open source as well as cloud services for vector stores. What if we can avoid it completely and we can simply keep the vector stores inside Pandas? It could be real fun. You can experiment those things and see how the outcome is. But in case of examples, if you go to Towhee examples, you will see lots of examples that is linked with Milvus and Milvus database. So as I always say, there is always a challenge that each and every program solves, guys. Keep this in mind whenever you're looking at any of the Python libraries or any of the ecosystem products or services that is getting introduced. So vector stores as a whole solve one simple problem. It takes the unstructured data that is available in the real world and then stores their vectors inside the data store. That is what vector store does. Vector store does not convert the unstructured data into embeddings. It does not convert. It only stores the embeddings. The conversion of the embeddings is done by the models and also the ecosystem surrounding it. So for an example, so you see the TIM model. This actually does the TIM model, pulls the ResNet 50 model and then converts the image, these images that where is the image? So these images that I already showed you, it converts those images into numbers and then gives it to you as a tensor or a vector. And you can take this vector and store it inside the vector store. That is something that you guys have to learn how to do it. I'll be touching some of those concepts also in near future. And I hope that you understood the overall ecosystem surrounding Towhee, as well as how Towhee helps, how the data structure like data collection, the ops module, and the operator hub, that is Towhee hub, that is already having lots of models stored. How these things help has been shared in this video. I hope that you like this content, and do leave a like, share it with others, and most importantly, subscribe to my channel so that further updates that I provide on not just artificial intelligence models. I also provide updates on various Python related libraries, big data related concepts to in near future. So also in Towhee also I'm going to share additional information in couple of days. So stay tuned for that. And once you subscribe, that particular videos will get hit to your YouTube dashboard directly. With that, I would like to close this video and with 4 words as usual: practice, 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 practice. See you guys. Have a great time.